All right, good day, everyone. Let's get started on our lesson for today, which is called Evaluating Integrals Using Geometric Techniques. So just to recap, so far we have understood what an integral is, meaning that integrals are finding the area under a curve from that particular function to the x-axis. So today we're going to do that, but we're going to use geometric techniques versus algebraic techniques that we have been using where we had the function, or I guess a geometric technique is we have been using rectangles, but now we're going to use all sorts of shapes. So there's going to be two goals today. So the first goal is going to be, I'm going to go through these steps here, but the first goal is going to be to understand how to set up a definite integral. So we're going to be doing that, even though we're not going to actually be using it per se. It's going to be important for us to understand how to set it up for the next two lessons. And then our second goal is to find the area of these shapes and or these functions that are built as separate shapes. So that is going to be our goal today. Set up integrals, definite integrals, and then to find the area of these regions that we have. All right, so let's get started with step number one. I'm going to go with step number one and solve number one down here at the same time. So first step is we're going to identify the portion of the graph corresponding to the definite integral and set up the definite integral. So on our first graph here, we have a region, and if hopefully you're seeing that the region looks like a semicircle. So this is what I'm finding is this colorful region here, and I'm finding it from -3 to 3. Okay, so that when I set up my definite integral, we're going to use the integral sign. And then if you remember, at the top and the bottom are going to be your bounds. So the top bound is the +3 and the lower bound is -3. So we're finding the area of this region from 3 to -3. That's what this is indicating. The area of this function that we don't know the actual formula for the function of this curve, but this is what we're going to do is we're going to find the integral or the area under the curve from 3 to -3 of this function. Okay, so that is step number one we have done. Set up the definite integral and understand what portions we're doing. Okay, step two, divide the graph into geometric shapes whose areas can be calculated using formulas in elementary geometry. So in this case, we don't have to split it up into different geometric shapes. That's going to be when we get to number two. Right now we have a shape. This is a semicircle. And so if we know that the formula, that's what we're looking for, the formula of a semicircle to find the area, then we can go ahead and just find this area of this particular shape. So maybe you don't know the area of a semicircle, but maybe you remember the area of a regular circle. So the area of a circle, just in case you forgot, is pi r squared. So to find the area of a semicircle, you would take this and you would cut it in half. So you can either write it as divided by 2, or how I like to write it, I like to pull that 1/2 in front and do 1/2 pi r squared. Okay, so again, what we're doing is we are finding the area from 3 to -3, and we can find the area using a geometric formula this time. We don't need to know the function's formula. We just know that the function is a semicircle. So we can use this formula to actually find the area. Okay, now all we have to do, all right, so we're done with step two, is we figured out what is the formula that we need to use. All right, step three, find the signed area of each shape. I will come back to what signed area means in a second. Because remember that the area above the x-axis is considered positive and the area below the x-axis is considered negative. This is throwing us back into first semester when we talked about those graphs, when we had acceleration and velocity and speed. This should look familiar over here, number 2 of the acceleration, velocity, speed functions that we worked with, and how when it goes below the x-axis, our velocity changes to a negative. And so therefore, our area under the curve would be a negative area. So we'll get to that in number 2. I'll show you that in a moment. So now to find the area, we just have to figure out what are the parts of this formula that we need. So we need to know what the radius is. Okay, what is the radius of this circle? Hopefully remember that the radius is from the center to the edge. Okay, and no matter where we go, the center to the edge, the radius is going to be 3. So all we're going to do is plug in 3 into our formula. So 1/2 times pi, which we'll use 3.14, times 3 squared. And I'll go ahead and give you a second to do it in your calculator to make sure that you get the same answer that I do. And if you plug that into your equation, you will get, excuse me, 14.13, approximately 14.13. Okay, so that is the area of this shape. Okay, so that's really what we're doing is we are finding the area of the shape. There's going to be some composite areas. That is one of our objectives today. The other objective is to understand how to set up these integrals based upon the portions of the graph. Okay, I'm going to clear this out, and then we are going to, we're going to go to number 3 next, because number 3, we don't have to split into anything, and then we'll come back to 2. All right, so let's go look at number 3. Okay, number 3, and you'll just have to refer back to the steps up above. So the first step is that we want to set up the definite integral for the region that we're trying to find. So in this case, our region is from 0 to 3. So our integral is going to be from 3 to 0, highest at the top, lowest at the bottom, of this function that we don't know the equation. Because remember, the equation, the function is right here. This is the function. Okay. So step number 1, we found the region, the bounded region here, where it's from 0 to 3. All right, second step is what formula or what shapes am I going to use? Okay, and so in this case, if you look at this shape, and you forgot what this is a trapezoid. Okay, so just in case you forgot what a trapezoid area is, there are 2 ways you could do it. It's very similar to a triangle. It is 1/2 base times height, except for there are 2 bases. So I just want you to be aware that this is a base and this is the base. In a trapezoid, the bases are the parallel sides. So even though you may think that this bottom is the base just because it's sitting on it, it's not. These are the 2 bases because they're the 2 parallel sides. So it's the same thing as a triangle. It is just that you have 2 bases you have to add together. So it is 1/2 base times height, but it's 1/2 the bases added together times the height. Okay, so that's what we're going to use in our formula. So that's step number 2, is identifying what are the formulas that I'm going to use. Step number 3, find the area using this. Okay, so I'll write it over here. We'll plug it in. So 1/2. So the height is actually here. This is the height because it is tipped on its side. So the height is 3. And then times the length of my 2 bases. So this base is 3. And this base is 2. So 3 plus 2. So then if I do that, 1/2 times 3 times 5, that'll give me 7.5. Okay, so that is step number 4, which is find the area under the curve using geometric techniques. Okay, let's move on to number 2, which we have to split up. So number 2 is not shaded, but if you look here, I'm going to trace this in. So we have this triangle, 1. We have another triangle, 2. And a third triangle here, 3. So we have 3 different triangles that we have to find the area of, again, using geometric techniques. So first step is let's set up those integrals. So we have to set up 3 integrals this time because there are 3 different shapes. So it's up to you if you want to label them as the different shapes so you remember. Again, it is going to be important in the next 2 lessons that we understand how to do these bounds and understand what they mean and how to read this graph. So the first triangle here is going from 0 to 2. So you can see here from 0 to 2. So our first bound is going to be from 0 to 2 of whatever this function's equation is, and then dx. Okay, number 2 is going from 2 to 4. So our bounds would be 4 on the top, 2 on the bottom of whatever this function is, dx. And then the last one is going from 4 to 5. So shape number 3 will be 5 at the top, 4 at the bottom of this function, dx. Okay, so that's step number 1. Step number 2, what formulas are we going to use? They're all going to be the same formula. The area of a triangle, remember, is 1/2 base times height. So all we have to do is identify what is the base and the height of each of these triangles, and then we can find all the separate areas. Okay, so let's go to number 1. So the base here, I would probably say is 2, and the height would be 4. So we're going to do 1/2, 2 times 4. Okay, 2 times 4 is 8. Cut that in half is 4. So the area of triangle number 1 is 4. Okay, triangle number 2 is where it gets a little bit tricky. As we mentioned in step 3, find the signed area. This shape is upside down, meaning it's underneath of the graph. So the area is going to be negative. You think about it like this. The base is going to be 2 still. So 1/2 base is going to be 2 long, but the height this time isn't, it's not positive, it's negative because it's underneath of the graph. So you could make it -2. You could also just find the area and then just make it negative at the end. That also works. So 2 times 2 is -4. Half of -4 is -2. So the area of the second triangle is -2. Now the area of the third triangle, the base is only 1. So 1/2 times 1, and then the height is 2. Okay, so 1/2 or half of 2 is going to be 1. Okay, so now the total area, that's step number 4, where we have to add all the areas together. So the total area is 4 plus -2 plus 1 would give me 3. So the total area of this figure is 3. Okay. All right, let's try one more, and then I will let you decide if you want to do one by yourself. And I will also have the answer for you so you can see how you did, if you'd like to try one, practice one before you try your homework. Okay, let's go to number 4. Okay, number 4, this time they're giving you a number and they're telling you that you're only finding the area from 3 to 8. So just from 3 to 8 is all we want. Okay, so if you notice here, we have this weird little L shape figure, and then we have a triangle. So this is where step number 3, it says that you need to split it into geometric shapes, or that's step number 2, divide the figure into geometric shapes that you can find the area of. So you could do this, which I think is the easiest thing to do, is just to draw a line there. So you have your 3 shapes now. You have 1, 2, and 3. Okay. All right, so now step number 1, let's set up the integral. So we're going to have 3 different integrals. Okay, shape 1 is from 4 to 3. Shape 2 is from 6 to 4. And feel free to pause it and try it by yourself. And then the last one is from 8 to 6. Okay, and remember, they're all f of x dx. Okay, I'm not going to write that every time. That is what it is each time. And we'll keep going on so we can go a little bit faster. Okay, now we need to know the area of rectangles. So in case you forgot the area of rectangles, it is length times width, or you can think of base times height. Same idea. So the first 2 shapes, we're going to use length times width. And the third shape, we're going to use 1/2 base times height because that is a triangle. All right, now all we have to do is just plug in the numbers to figure this out. All right, so 1, length times width or base times height would be 1 times 3. So 1 times 3 gives me 3. And then the second shape, length times width or base times height is going to be 2 times 1, which gives me 2. And then the last one, base times height would be 2 times 3. So 1/2 of 2 times 3, which is 6. So half of 6 gives me 3. But don't forget, this is underneath the graph. So the height is actually a -3. So that's going to make our area a -3 because it's under the graph. So it'll be a negative answer. So now the total area will be 3 plus 2 plus -3 gives me 2. Okay, if you want to pause it right now, you can go ahead and pause it. I'm going to just work this one out at the bottom, just kind of talk it through. If you want to pause it, or if you feel like you got it now, or you want to try just one more thing to make sure you have the answer, you can do that. Otherwise, the homework is the second page that is stapled onto the packet that I gave you. So there are 5, actually there's only 4 problems. You can cross off number 2 because number 2 is the same thing as the number 2 that we just did. So you're going to do 1, 3, 4, and number 47 that's on the back of the page. So those will be for homework. But if you'd like to continue on with the video and watch one more example, you can do so. Okay, last example here. If you want one more practice round. All right, so this one we are evaluating from 12 to 5. Okay, so this one is only going from 12 to 5 because that's what the problem says right here, 12 to 5. So we're only looking at these 2 shapes. Okay, so 1 is a triangle, 2 is a semicircle. So let's set up the first one. The first one would be from 5 to 8. And f of x dx. Okay, and we already said I'm just going to do the next step. It's a triangle, so we're going to do 1/2 base times height. Okay. The second shape is a semicircle. We're going from 8 to 12. And f of x dx. And if you remember from the front side, the formula for the semicircle is going to be 1/2 pi r squared. Okay, so let's go ahead and plug those numbers in. So the first one, 1/2 base times height of the triangle, it is 1, 2, 3, 1, 2, 3. So it's a 3 by 3. So 1/2 of 3 times 3. Okay, which is going to give me 9, is going to be 4.5. Okay, also remember it's negative. That is a negative height or a negative base, whatever you're looking at, is underneath. So make sure that you have it a negative 4.5. Okay, then our second one with the circle. So our radius, remember, is only half. So our radius is going to be 2. So it's going to be 1/2 of 3.14 times 2 squared, which is 4. I'll just go ahead and write that 4. So 1/2 times 3.14 times 4 gives me 6.28. Okay, then I'm going to subtract those because the 4.5 is negative, and I get 1.78. So this answer here, the area from 12 to 5 is 1.78. Okay, good luck. If you have any questions, let me know. Your homework then is to finish the rest of this packet. Remember, you can skip number 2 because we already did number 2 on the other page.